Hello everyone, I'm Zhenting Hu from Stevens Institute of Technology. This video is a presentation of the final project for our Python course. The project was completed by me and Jiabang Xu. We'd like to sincerely thank Dr. Joseph Helsing for his guidance throughout the project. Now let me start introducing our project. Our project mainly focuses on the annotation part in medical image AI segmentation tasks. I worked on related projects before, so this tool is actually designed to solve some of the pain points I personally encountered in the past. First, we launch the program. You can also add a save parameter during launch to change the folder where you want to save your final annotations. Once it's running, you can see our GUI. You can click the button at the top left corner to open a folder. The program will automatically read all document files in that folder and its subfolders and sort them. So even if you mix all the document files in one folder, it can still recognize them correctly. But if you already have an annotation files and you're trying to edit, you need to put both the document files and the annotation file in the same folder. Otherwise, they won't load properly. Like this. This is the one file, and this is the easy annotation. You can also just drag and drop the folder into the GUI to open it, which is super convenient. Now we can see the GUI and its function. The GUI is mainly made of 4 parts. At the top, there is a menu bar. I do recommend you using keyboard shortcuts to work more efficiently, but we also added buttons to help with the process. And I try to give each button a small animation. And I really like that part. On the left side, you'll see all files currently loaded. In the center, you'll see a preview image which shows the middle slice of the DICOM volume. You can click on the thumbnail to switch between the files. The big area in the center is where the image is displayed and where you do the annotation. This is the main working area. At the bottom, we show all tags of the current files. And when you select what tag, it stays selected even as you switch between images or files. So you can easily compare values across different DICOMs. Now let's take a closer look at the center, the image and annotation area. If your folder already contains an annotation file, the program will automatically jump to the first image that has annotations. You'll see some helpful tag info in the four corners of the image. You can scroll through the slices using the up-down arrow keys or a mouse wheel. When you press the middle mouse button, you can adjust the window center and the window width. And you see the all numbers updated in the bottom left corner. Once the image looks right to you, you can start annotating. I've made some settings based on my personal experience, but if you are working with annotation files from other sources and they don't align well with the image, you can go to the DICOM menu and do some basic transformations. Like flipping or rotating to match the annotation with the image. When you want to add or delete an annotation, you can switch to the outline menu. After click the first button, you can left click to add a new outline. After clicking the second button, you can delete an outline. You can also use the shortcuts, hold Ctrl and then left click to add and right click to delete. Let's skip the third button for now. The first button lets you to zoom into a specific area. You can also use Alt and right-click to do this. When you hold Alt key, a crosshair will appear to help you select precisely. Now let's go back to the third button, which is Default Dual tool. After zooming in, you can drag the image to move your view. Alt and left-click lets you move the view more precisely. The fifth and the sixth button are easy to understand. When you zoom using the buttons, the image from the center. And when you use Alt and scroll wheel, the image zooms from where your mouse pointer is. Once your annotation is done, you can press Ctrl and S to save the image and annotation to the folder you set at the beginning. It saves as an MPC file, which makes it easier to read during AI training in Python. Although MPC files are relatively big since medical AI datasets are usually small, I think it's not a big issue, so I prioritize use MPC for convenience. The file is saved with the SOP instance UID as its name, which is this one. This value is unique and corresponds to only one image, which helps avoid any naming conflicts. If you try to move to another image without saving, the program will prompt you. Clicking Confirm will save and move on, Refuse will skip saving and move forward, and Cancel will take you back to the current file. That's the overview of our final project. We welcome any feedback and are happy to discuss further if you have any questions. Thank you very much for watching.